ME 8593 Design of Machine Elements. Unit 3 Temporary and Permanent Joints. Threaded Fasteners. Tutorial problem. For eccentric load perpendicular to axis of the bolt, presented by Department of Mechanical Engineering, Tandai Periyar, Government Institute of Technology, Vellore. Problem 5. The following data is given for bracket illustrated in figure. Okay. P is 25 kilonewton, E is 100 millimeter, L1 equal to 150 millimeter, L2 equal to 25 millimeter. There is no preloader in the bolt. The bolt are made of plain carbon steel 45 C8. It is yield strength equal to 380 Newton per millimeter square, and the factor of safety is 2.5. Using the maximum shear stress theory, specify the size of the bolt. What they are giving here, this is the bracket arrangement. Okay, this is the bracket arrangement, this is the side view, this is the front view. Okay, here 1 2 3 4 bolts are fixed here. The top two bolts are taken as a number 1, bottom two bolts are taken as a number 2. Okay, here P equal to load carrying is 25 kilonewton. E is the center of gravity. Center of gravity of the bolt is 100 millimeter. L1 is, this is the point is called a twisting point. This is very important. This is used in the problem very much. Okay, this is the point. C is the twisting point. Which this point only this bracket is twisted because of this load. Okay, from this twisting point, L1 is twisting point to number 1 point, center point of the bolt 1. Okay, and L2 is twisting point C to the bolt 2, center point of the center line of the bolt 2. Okay, there is no preloader in the bolt. Okay, then the bolt material of the bolt is 45 C8, yield strength is 380 Newton per millimeter square, and the factor of safety is 2.5. Here they are giving the condition of maximum shear stress theory, and then also find the size of the bolt. Okay, let's go for the problem. Given data P equal to 25 kilonewton, yield strength is 380 Newton per millimeter squared, Fs factor of safety is 2.5, E is equal to 100 millimeter. First step 1, permissible shear stress. Permissible shear stress formula equal to tau equal to S Sy. That means shear strength divided by factor of safety. Here shear strength equal to half of the yield strength. Okay, so we know the value of yield strength and factor of safety. You will apply the values here, and we can find the value of permissible shear stress. Permissible shear stress is 76 Newton per millimeter square. Okay, then step 2, can find the direct shear stress in the bolt. Direct shear stress in the bolt 1 2 3 4. Okay, P1 dash P1 dash and shear force at bolt 1 and bolt 2 are equal. Okay, here P divided by number of bolt. Number of bolt is 1 2 3 4. 4 bolts here. P equal to 25 kilonewton. 25 into 10 to power 3 Newton divided by number of bolt is 4. Now we can find the value of P1 dash equal to 6250 Newton. Then the direct shear stress is given by tau equal to 6250 divided by A. A is the area of core diameter. Okay, area at the core diameter of the bolt. Okay, this is the direct shear stress of the bolt, where here is the core cross section. Okay, then step 3, tensile stress in the bolt. P1 double dash. This is the tensile stress formula. P1 double dash divided by A. Here P1 double dash equal to bending stress. Okay, bending force. Bending force equal to, okay, you remember this formula. From this we can write this formula. Okay, M into L max divided by L1 squared plus L2 squared plus L3 squared plus L4 squared. This is the formula. Here M equal to load into E. E means center of gravity. Okay, load into E. M equal to moment of this load. Okay, P into E into maximum length. Okay, maximum length. What is maximum length here? L1 is equal to, L1 is the maximum length, L2 is minimum length. Okay, L2 is 125 millimeter, L1 is the maximum length here, 150 millimeter. Okay, from this formula we can write this formula. Okay, P1 double dash equal to P into E into L max. L max is equal to L1. Okay, maximum length of this arrangement. Okay, divided by L1 square plus, we can write as like this only, L1 square plus L2 square, L3 square or L4 square. Okay, here they are giving top two bolts are named as a 1 1. Here this bottom bolts are given as a 2 2. Okay, so 2 into L1 square plus 2 into L2 square. Okay, now we can write as here 2 into L1 square plus L2 square here. Okay, now we know the all the value, you know the P value 25 kilonewton, E value is 100 and L1 is equal to 150. Here L1 and L2 value, apply the values and we can find the P1 double dash bending force of this arrangement 8108.11 Newton. The bolt on are subjected to the maximum force. In general, the bolt which is located at the farthest distance from the tilting edge C is subjected to the maximum force. So let's see which the in bolt which is located at the farthest distance. This is the farthest distance from the tilting edge C. Okay, this is the farthest distance. Yes, bolt 1 is the farthest distance, so which will get the subjected to the maximum force. Okay, let's see here. Okay, so tensile stress in the bolt is given by sigma T equal to P1 square divided by A. Okay, A is the core diameter of the bolt 1. Okay, and step 4, principal shear stress in the bolt. Okay, they are using the maximum shear stress theory. Okay, so we can use the maximum shear stress theory formula here. Tau max equal to square root of sigma T divided by 2 whole square plus tau square. Okay, this is the maximum shear stress. This is the, what is this, direct shear stress. Okay, tau is the direct shear stress. This tau is the perimeter shear stress. Okay, okay. Now you can apply the all the values. Sigma T equal to 810.11 divided by A. Okay, then tau equal to 6050 point divided by A. Okay, update the value and resolve this equation. You can get the maximum shear stress equal to 7449.69 divided by A Newton per millimeter square. Then step 5, can find the size of the fault. Equating the value of tau max, that maximum shear stress, to permissible shear stress. Okay, maximum shear stress is equal to the permissible stresses. What is the permissible shear stress here? Already we found this is the permissible shear stress equal to 76. Okay, can apply this value here and resolve this value. We can get the value of 98.02 from this table in PhD design data book page number 5.42. We can get the value of nominal diameter of the bolt, corresponding bolt. Okay, from this area we can found what is the area, 98.02. Here is, this is the stress area millimeter square. Is the value 98.02. Let's see, this is the 84.03. After that 157. This is the area of standard bolt. Okay, standard bolt 98.03 is not there here. So after the 98.03, this is the standard size of the bolt in the data book 157. In corresponding 157, what is the value of the bolt is M16. M16 is the suitable bolt for this arrangement. Okay, see, M16 is the standard size of the bolt. Okay, now we can found the, because you haven't data book, we can found the value by the formula also. Okay, A is equal to pi by 4 dc squared. Okay, A is equal to pi by 4 dc squared. From this formula we can found the dc squared. Okay, sorry, dc value. Dc is equal to core diameter of the bolt. From the dc we can found the nominal diameter with this formula. dc equal to 0.8 d. In previous problem we have solved like this only. Okay, dc equal to 0.8 d. Okay, with that formula we can find the diameter of the bolt. Okay, nominal diameter of the bolt. Okay, if you have in data book means we can find the value by these formulas also. Okay, if you have the data book, directly go to data book, corresponding area of this value we can find the suitable standard bolt for the this arrangement. Okay, thank you. And go for next problem. Problem 6. A wall bracket is attached to the wall by means of 4 identical bolts. Okay, 2 at A and 2 at B. Okay, here 2 bolts are there, here 2 bolts are there, totally 4 bolts are there. Okay, this is the side view. In front view you can see 1 bolt, 2 bolt, 3 and 4 bolts. Okay, then assuming that the bracket is held against the wall and prevented from tipping about the point C by all four bolts and using an allowable tensile stress in the bolt as a 35 Newton per millimeter square. Determine the size of the bolt and the basics of maximum principal stress theory. Okay, what they are giving here, the wall bracket is attached in the wall by means of the 4 identical bolts. 2 at A, this is the A point. Here 2 bolts are there, bolt 1 and 2 you can take, and 2 at bolt B. Okay, here 2 bolts are there, bolt 3 and 4. Okay, as one figure. Assuming that the bracket is held at the against the wall, the prevented from tipping out the point C. Okay, the allowable tensile stress is 35 Newton per millimeter square. determine the size of the bolt. You can find the diameter, nominal diameter of the bolt, and using the maximum principal stress theory. In previous problem, you can find the value by maximum shear stress theory. Here, maximum principal stress theory. Okay, this is the difference between previous problem and this problem. Okay, solution. Given data is P equal to 25 kilonewton and E equal to center of gravity of this arrangement is 500 millimeter. Sigma T maximum allowable shear stress equal to tensile stress equal to 35 Newton per millimeter square. Step 1, direct shear stress in the bolt. Okay, first two bolts at A are denoted by 1. Okay, and two bolts at B denoted by 2. This is denoted by 1, this is denoted by 2. The direct shear force on each bolt is given by P1 dash equal to P2 dash. Both the shear stress are equal here. Okay, P divided by number of bolts. Here 2 bolt, here 2 bolt. Totally 4 bolts are there. So 25 into 10 to the power 3 divided by 4. We can get the value of single bolt is 6250 Newton. Okay, then direct shear stress in the each bolt is given by tau equal to 6250, that means load divided by area. Okay, maximum shear force divided by area equal to, okay, this is taken as a equation 1. Okay, next step 2, tensile stress in the bolt. Since the tendency of the bracket is to tilt about the edge C, the bolt A is denoted by 1 or the farthest distance from C. Okay, the bolt 1 is this is the denoted as 1, this is denoted as 2. So from this tilting point, the bolt 1 is the farthest distance from this tilting point. Okay, so therefore the bolt at A are subjected to the maximum tensile force. Okay, from equation, okay, in previous problem I said you can found the bending force. Okay, P1 double dose equal to M into L max divided by L1 square plus L2 square plus L3 square plus L4 square. Okay, here moment equal to P into E into L max, maximum length from the tilting point of the bolt. Okay, here the maximum length is, here this is the tilting point, so maximum distance is 50 plus 500, so 550 millimeter. Okay, then from this formula we can write this formula. Okay, P into E, this is the moment value into L1. L1 is equal to maximum length. Okay, here then 2 into L1, you can write as here L1 square plus L2 square plus L3 square or L4 square, or else 2 into, so we can these two bolts are we can taken as here L1, this 1, these two bolts are we are taken as here 2, so 2 into L1 square plus L2 square. Then we can apply the value, all the values, can apply the value and resolve this equation. We will find the value of P1 double dash. The value is 11,270.49 Newton. Okay, then tensile stress in the bolt A is given by sigma T equal to 11,270.49 divided by area. Here the area is the core diameter of the bolt. Okay, this is taken as a equation 2. Then principal stress are in the bolt. Okay, the principal stress sigma 1 in the bolt is given by, okay, why, because basis of maximum principal stress theory. Okay, here they are given to use the maximum principal stress theory. In previous problem they are given to using the maximum shear stress theory. Okay, here the formula of maximum principal stress theory, sigma 1 equal to sigma T divided by 2 plus square root of sigma t divided by 2 whole square plus tau square. Okay, here tau is equal to direct shear stress. This is the sigma t equal to tensile stress. Okay, we will apply the value of this value. Okay, sigma t and tau value, then we can found the sigma 1. Okay, sigma 1 is equal to 14050.62 divided by a Newton per millimeter square. Okay, now step 4 equal to size of the bolt. Found the size of the bolt. Okay, the permissible tensile stress for the bolt is 35 Newton per millimeter square. In problem, they are giving permissible tensile stress of the bolt is 35 Newton per millimeter square. Okay, so equating this this value from this principal stress. Okay, from this we will find the area of the bolt. Okay, area of core diameter of the bolt A equal to 401.45. From this value we will find the value of core diameter and also the nominal diameter of the bolt. Okay, we will check the value in data book, PSG design data book, page number 5.42. Okay, A equal to 401.45. Okay, let's see, area equal to 405.03. Is it 401.45? Okay, here 401, where is the, this is 353, this is 561. This is between the 401 is between this value, so we can take the value of 561. The area is 561 is the standard bolt area. Corresponding this value, we will find the maximum nominal diameter of the bolt is M30. Okay, M30 is the suitable bolt for this load setup. Okay, M30 is the standard size of the bolt which is suitable bolt for. Okay, remain the size of the bolt for this arrangement. Okay, that will withstand the this load setup. Okay, M30 is the suitable bolt for this arrangement. Thank you so much.